Ladies and gentlemen, welcome to another exciting episode of Adventures in DevOps. I'm your co-host for the week, Jonathan Hall, and here in the studio I also have Jillian.
Hello.
And we're excited to be meeting with our special guest today, Brian Greene. Welcome, Brian.
Good morning.
Would you tell us a little bit about who you are, what you do, why you know anything about DevOps, and maybe why you're here to talk to us?
Sure. My name is Brian Greene. I'm the CTO of NeuronSphere. You can find us at neuronsphere.io. We are a DevX platform engineering toolkit focusing on data. And there's a huge DevOps component to that. I've spent my career building software teams across multiple data domains. And in every one of them, how do we do CI/CD? How do we continue to do DevOps operations? It's always been a real accelerator for quality. So that's why I'm here.
Awesome. We were talking before we hit record about some of your past with medical devices, and that really sparked Jillian's interest because she works in an adjacent industry with a lot of data science regarding genomics and stuff like that. Do you want to give us just a brief sort of history of how your career has advanced? What got you to where you are now?
Sure. The super whirlwind is it's kind of all been about data. I started with web apps, right? Building transactional web apps and how do we get those deployed and tested, and very quickly figured out that managers were often talking to the guy in the corner who was writing all the SQL. And so I kind of go peek in over there and got into BI, and global business intelligence is fun, but many of those tools lacked sufficient automation, right? So I actually spent a lot of time building up kind of DevOps capability. This is back in, remember Subversion, right? So this is Subversion with SQL Server analysis services and integration services, and built a little framework to do CI/CD for those artifacts. Yeah, it was fun, but it was a little slow, and we'd made a big acquisition, so I moved into enterprise service bus, kind of message-oriented middleware, built a huge middleware system. We connected 250 endpoints in a couple of years internally across a huge bus, and we built canonical object registries and did a bunch of data lineage stuff. And with that view of that kind of ecosystem, I moved into enterprise architecture and platform rationalization, which is really interesting, sort of theoretically, and financially has great implications, but it really it didn't scratch my coding itch anymore. So in 2016, I got a great opportunity to go build from scratch at Oris Robotics. So Oris is a little company down in Redwood City. They were building a really neat surgical robot. Surgical robots produce vast quantities of data. And when I got there, they said, we have vast quantities of data. Here it is in a pile. We got to do something with it. And you start doing estimation and you figure out that a vast percentage of the employees need access to that data, right? Huge percentages of the business processes that you're running will be on that as a backbone. And so started building an analytics practice there, and it's all about DevOps at that point because the results of the analytics are critical, right? We're not experimenting in prod when we're talking about analyzing the performance of a robot. We need to trust things a lot more, and that actually leads to more aggressive testing, having multiple environments, doing real validation, lots and lots of automation. Johnson & Johnson acquired that company. It's a great exit. We had a great time in J&J. And then in fall of 2020, I guess, so about 2.5 years ago, we said, hey, let's go build a real platform engineering toolkit, kind of the thing we've been looking for. And again, a big piece of that is DevOps. A big piece of that is a deployment engine and artifact storage and dependency management, test automation management. So that's what we've been at for the last couple of years. Started targeting surgical robot companies and now are sort of moving into some other wearables. And so it's been exciting so far.
Interesting.
What kind of devices are you targeting now? So you were mentioning earlier you have surgical robots, but I mean there's all kinds of medical devices. Is it all surgical robots, or do you do any other robotics,
so
like lab equipment, microscopes?
So we're open to all that. all of those are possibilities. And when we're actually looking at moving out of medical devices, and we've had conversations about do we move into nuclear, do we move into pharma, do we move into genomics? There's a lot of crossover in the regulated space, right? So a lot of med devices are very similar to all these other regulated spaces in that there's lots of laws that are going to tell you how you have to do things, and then you interpret those laws into policies, and then those things turn into how do we get things done? And so we feel like there's a lot of commonality, but we're pretty early, right? It's a good sized implementation to turn it on and sort of get it spread out across the company. So,
would you paint the picture a little bit? What it looks like? What's different about software development for medical devices than, say, a SaaS or sort of a typical web API product that a lot of people work on something like that? What are the differences? You talked about extra automation, more testing environments. I can imagine if you're doing a robot, you can't just set up a mock and expect the test results to be meaningful. What are the differences from a developer's standpoint when working on these sorts of products?
Yeah, that's a great question. So, it turns out to be a lot of control. We talk about V and V. In the industry, you hear people talk about, oh, we're going to go through V and V. And as agile software people, it kind of freaks you out because V and V is verification and validation.
Mm-hmm.
And it means these very specific legal things, like we have to have written requirements. You have to have written requirements that say what the system does. And oftentimes there are, one layer of user requirements and then a separate layer of how did the software implement them, right? So there's kind of a many-to-many relationship there. You are required by law to have that written down for a medical device, right?
Mm-hmm.
You are required to have things like what we call an FMEA, so failure mode and effects analysis. You have to prove that you followed a methodology to think about how is this thing going to break, right? So we always, it's interesting, right? Because in the cloud and in DevOps, we go, oh, well, just assume everything's going to break and, architect around that. But we often don't, right? Because it's really hard to do that effective. You know what I mean? You sort of grow yourself to that. With a medical device, it's not available, right? Like you are required by law to say, look, we have analyzed and indexed. Here are all the possible things that could break or go wrong. And in each one of those, here's the effect. Here's what we think the cause is. Here's the likelihood. There are scoring matrices. There are layer after layer of documentation and control well above the software, right? So now when you actually get to the software, it's, the better you can do things like automated testing, the better thing you can do things like traceability. We talk a lot about, can you tie the testing of the software and automated testing back into your requirements matrix? And in the data space, we talk a lot about data lineage, but in device software and in controlled software development, a lot of the conversation is about requirements lineage and requirements traceability. And it's on one hand, crazy boring, and on the other hand, absolutely essential if you're talking about software that can hurt people, right? And ultimately with medical devices, lots of things are about, as soon as you work in a quality controlled environment like that, you learn the understanding of what's called a risk assessment. So the risk assessment is more than, hey, I'm going to flip this switch in prod. I'm going to call the other dev and say, hey, what do you think's going to happen? I don't know. It's probably going to be okay, right? And we flip it and then we stand there and watch. Oh, look at where. That's not an appropriate risk assessment.
Yeah.
Right. So, a risk assessment include, and it's interesting as long as you enjoy writing things down, which I do. I think as a developer, there are lots of things that are not code that should be written down.
Mm-hmm.
And I spent, my early years, the code is self-documenting, put it in the comments, whatever. It's just not true, right? There's lots of important documentation that's way outside the code. And in a lot of places, it's given short shrift, or we don't know what to do, right? Like, so you go ask a developer, where did you document this? And they put their hands in there. I don't even know where I would do that. right?
Mm-hmm.
In device software companies, even when they're very small, they will already have a clear understanding of this kind of information gets documented over here. Here's how we have a global glossary. Here's how we do, if you're going to do a risk assessment, here's the standard procedure for how you should do that. Here's what you should document, right? It's very, and it sounds like really constraining. It's not. You can do lots of really impressive things in it, but it is a more methodical kind of, you got to know the rules. And where that leads for DevOps is, really, frankly, medical device companies, because of all these regulations, right? And then let's assume you get big. Now it's not just all these regulations around quality and product stuff. You've got, other controls like Sarbanes-Oxley. I mean, we don't talk about that as much, and we've kind of backed off of it a little bit. But in really big companies, you've got all these other controls around separation of environments, right? So, like, can a developer access production? If the answer is yes, at all, right? Then in a lot of audits, you just got a big old ding. It's not appropriate. Developers shouldn't have free access to production. If you have a really small team, you can justify it. You should have traceability. You should have unchangeable logs that prove, right? Like, it should be a special, because administration of a running system, back to DevOps, right? Administration of a running system, monitoring of a running system, diagnostics, those are all operational concerns. And somebody who's thinking about and performing development activities routinely, like, yes, you can wear both hats, but even then, this is where you get to, if you're doing operational stuff, you should definitely be using a different account. It should definitely be having all kinds of privileges set. And so I hate to say it, but like, this is all constraining, and it turns into like organizations that'll get a little stodgy over time because it's hard to build all this infrastructure and procedure and blah, 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 blah. So the willingness and desire to change it. So like DevOps principles, continuous delivery specifically, right? Like in the cloud, I don't know, I guess it's been a challenge for the last decade or so to like get the quality people to let me do it. And really is understanding how, we've got all these quality controls in place. I think DevOps and continuous integration and continuous delivery, particularly with cloud technologies, I think they get us higher quality and higher adherence to the controls, right? Like releasing up through a QA environment every day and running automated integration tests that you can prove have traceability back to your requirements. That's a substantially higher quality than releasing every couple months.
Yeah.
Right. So there's a bunch of things in DevOps that I think enhance quality, and I've had pretty good luck over the last decade, like really getting the quality folks to say, "Oh wow, that's a different way of doing it," but we can satisfy our controls better, right? Like we can get to better traceability, we can get to faster delivery. So much of it is quit talking about automated testing and do it well, right? Just like double down and actually invest in it a little bit. Quality people love you when you have good, right? So there's this nice, like if you really like good controls and automated testing, move into like medical devices or like move into any of these highly regulated industries, because the quality team there will give you huge kudos. Like automated testing is the only way to get any kind of velocity, because you're required to prove testing for your releases, right?
Yeah.
So if you don't want to get into this cycle of we're going to cut code and then we're going to throw it over the wall to some QA folks, and I am not exaggerating when I say they're literally clicking through the app and leaving their physical initials step by step in a test script, and those documents get scanned in so that you can prove who checked that script. Automating that, everybody loves that, right? Like nobody wants to do this click through blah 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 every time, but the only answer to it is what DevOps folks, really hardcore DevOps folks would tell you, which is, oh, well, you have to do CI/CD.
I found that really interesting though, because I would think that you would get an awful lot of pushback on trying to get rid of some of the manual, the person like actually there with their initialing things. Because I know I haven't been in the clinic or in the field in some time. But I can't think of a situation where I would have wanted to have some new feature or something on a medical device or on an intake form that was not approved by somebody else and like approved with a signature, and where I mean, it was a small team, but I was like a software person where I would have been like, yeah, sure, I'm going to deploy new features, and they're gonna go to like the clinic and be a part of this study without having been verified by somebody else. So do you get a lot of pushback on that? Because that's the first thing that I thought of is like, these people must be freaking out on you.
Yeah, so there's a couple of layers of pushback that you get, and one of them is logical, right? And there's a real conversation to be had here, and I don't think, I always love tugging on this thread a little bit, right? So automated testing, and when I talk about automated testing, I'm actually talking about like large scale. We deploy the app. So the other thing that this leads to is lots of environmental separation. So having dev test, QA, prod, regression, et cetera, the ability to have multiple deployments of your app that are cleanly config controlled. Like I can tell you everything that's in that environment. I can tell you every change that's been made, right? So there's a bunch of like guaranteed other capabilities that you need to have in place. So now I say, look, I can tell you the exact version of everything in QA, and we're going to look at this test script, and it's going to run an integration test. So it's going to deploy, running against a deployed system. And from a QA standpoint, you get this pushback. You do get pushback, by the way. Like the pushback is immediate, and it is always an automated test can't find things that are wrong with the app that a person can. Yeah. True. What do you mean, though? Like, let's talk about that. They go, well, what often happens, often kind of in air quotes, right? But what often happens is that as the tester is executing the test script, they'll see something else, right? And therein they have found a bug. And your automated testing can't do that.
Okay.
Totally true. Totally true. But the thing that they found, by definition, also wasn't in the test script, right? So finding it has value, but do you need to run the known test script every time as the only way to verify all these other known things, right? So the separating out human beings doing exploratory things and looking for strange behaviors, sorting that out separate from human being actually doing things that are easy to automate. Like once you start talking about, okay, well, we can, let's how do we separate those? Because the reason we use computers is that they do things better than people. And if you can look at this test script, and so particularly one of the things we used to do is have test scripts that take lots of screenshots. Oh, I hate this. It makes my skin crawl a little bit. But QA folks in controlled industries, they love this, right? Go to the next screen, take a screenshot, initial it. Go to the next screen, take a screenshot, initial it. Oh my God. Automating that so that you can show them, look, like here's the behavior, here's the thing it tested. And then if you want, you can look at the screenshot, tell me how a human doing this is better, right? I can give you, and so you can look at every test report and it looks exactly like a human would have given you. Here's all the screenshots in order. Here's all the values we tested, etc. I'm not saying don't have the human go do exploratory things.
Right.
But there's a huge, and like also QA usually when they say, hey, we're going to go do automated testing, they hear, you mean you're going to do some unit testing sometimes on your build servers or whatever, right? Like that's not like real testing, right? So really there's also this doing real integration testing of a deployed piece of software is very different than what a lot of developers are used to with lots of light integration. So there's a very different burden that you have to cross. Then you start getting rid of the pushback, right? Then it becomes QA actually flips. They become your ally and they go, oh, we get what you're doing. Can you go help these other teams do this?
That's great. I think so much like the job of like DevOps, maybe in particular, and engineers in general should be like translating things for the people who are actually using the software or the system, in this case, or the device or what have you, in a way that makes sense, that's not all just like tech speak, but like you said, is here's this goal that you want to have, and here's how we're getting there, and here's how we're making it even better than the system that you had in place previously, whether that was like a software system or a person taking screenshots and then initially.
One thing I've heard from a large number of people, and you've addressed this, but I'd like to hear you just address it just head on. You hear the rhetoric that continuous delivery, continuous deployment, automation, CI/CD, all that stuff, that's great, but it won't work in my industry because it's regulated. Or it won't, or more often even, it won't work in that industry that's regulated. And they're pointing to some other industry they don't even know. And medical devices come up all the time. And you're not the first person I've heard say that the medical device industry really lives or dies on automation. But would you just address that? You know, when somebody tells you we can't do automation here because we're regulated, how do you respond to that? What's the answer?
Yeah, I mean, the definition of regulated often boils down to we like controls, and computers are more reliable than humans. So the more things we automate with computers, the more like the more you controlled you can be by definition. Therefore, this is more appropriate for regulated industries, right? And which is I don't know, kind of an abstract answer, right? But it really is all about, everything is just about proving a state of control. Like all regulated industries kind of have this in common. And really it's even beyond regulated industries and into things that are quality with a capital Q, right? Like ISO 9000 kind of stuff. Like all of these frameworks, huge amounts of it boil down to, do you know how to maintain a state of control? Do you know what's going on? Right? Is the system in the way that you put it? Do you know how you put it? Do you know when you make a change what you expect is going to happen? When you make one of those changes, do you document that it did the thing you expected? Does it do that routinely? Or normally when you make a change, does it go to hell in a handbasket? Do you have records where, 6 releases in a row went to hell in a handbasket? So we had a meeting and we defined a corrective action plan because this is just bonkers, right? Like the releases need to be better. So there's so much stuff you go, wow, that just sounds like what I'd like a good software delivery team to do. Right? It's just, you have to do this or you can't ship the code or somebody might go to jail or so. Like in some ways, it's an excuse to do all the cool DevOpsy stuff that you'd love to do. You just have to learn how to frame it as this lets us go faster, which equals cheaper dev cycles, produce higher quality code, less risk sooner. And when you pitch those things in non-controlled environments, sometimes the answer is, well, yeah, we don't care. Right? But in controlled environments, you actually can get you get a huge tailwind when quality says, we fully support that. We think you should go spend money on it. It'll make the next audit go better.
Right.
Nobody wants a bad audit.
Just one more devil's advocate argument then. So suppose that this person says, okay, Brian, that's true. That sounds wonderful. However, our regulatory agency explicitly requires manual testing. Now, I've never seen an agency that does that, but I've heard people make this argument all the time. And maybe some agency like that does exist somewhere in the world under some jurisdiction. I don't know. Have you ever seen that? How often does this come up? How would you respond?
So, I said something earlier, right? I said that, the fun thing, and I mean, this is like all jobs, right? Like regulated industries aren't the only jobs where you have to follow the law. You have to follow the law everywhere. But in a lot of companies, there aren't many laws that are like super applicable that aren't relatively common. In regulated industries, we have lots more laws. And then you turn those laws, and this is critical. The laws are actually quite vague. The laws say things like, you have to prove that you tested your stuff.
Right.
That's pretty vague. And you have to take that law and you have to turn it into a policy that says, we will test all our stuff as appropriate. And then you have to have another policy that says, here's how we define appropriate, right? Because we have to categorize the stuff that we're going to build so that we know the appropriate level of testing we're going to do. Okay. Now, if some, I'm trying not to use like any pejorative terms, right? Like if some person who's not thinking futuristically writes a procedure that says we require manual testing.
Right.
Like they wrote a policy, my company requires whatever. Okay. Here's the worst. I mean, it's not the worst, it's the best part, right? The best part of working in controlled industry and quality management systems is that it's insanely simple and people screw it up constantly. You have to say what you're going to do, and then you have to do what you were supposed to do, and then you have to show that you did what you were supposed to do.
Mm-hmm.
You are bound to your procedures. Whether your procedure is accurately reflective of the law or not is a subsidiary conversation. In an audit, we need to understand that you have trained your employees to follow your rules. If you made stupid rules, like everything needs manually tested, well, if you don't do manual testing and those are the rules you have in place, you'll get burned in an audit. Even if now you can show them the automated testing, you can show them blah, blah, blah. But if you don't have a memo from the quality team that says, hey, listen, this group of people over here is not following this testing procedure because they make this part of the cloud software, and they have their own procedure for testing. And here's where their documentation is located. Now you're fine. You can do whatever you want. But, and so I've heard people claim that, like, oh, manual testing is required. And I'm like, no, somebody somewhere in your org years ago maybe wrote that down or whatever. But like most day-to-day activities that are quality controlled in an organization are like 3 levels removed from the actual law, and usually 5 years time-wise, right? Because you're going to write these policies and procedures and things, and then you revise them as needed, but it's not like thrilling work, right? So you kind of leave them alone and the laws and practices will actually change. The FDA will release new guidance. There's all kinds of. The FDA has guidance that they've recently released around if you're doing machine learning in medical devices, which like most of them are, if you go to a med device pitch event, all of them talk about, hey, we've got this cool new piece of hardware. And here's the data that the device produces, and here's what we're going to do with it, right? And it's usually, here's the algorithm that we're running at the edge right now that gives us a little bit of market advantage, right? Like we think this is a device that, does, and there's all this whole other matrix of how do you get the device into the market and what do you say it does versus what's it going to do in the future. See, you need to get a device onto the market that is using and producing new data that has an algorithm out there. But, and this gets into ML ops and where does this cross over with DevOps because they're really deeply related at this point. The whole ops cycle now of upgrading that model and doing regression testing on that model and capturing all the outputs and then pushing that new model back down to the device, right? So that the inferences that it's making are better. That loop is kind of well-defined by the FDA. Like they have clear expectations around that life cycle. And usually they're technologically kind of behind, but they're pretty up on this one. And if your device includes ML at the edge and you intend to do this, they now have a new pathway because all these device companies had this annoying question, which was, okay, I put the device out there and the software is locked, and changing it requires telling the FDA that you're changing it. Okay. And so there's certain kinds of little changes that you can make and you can tell them one way, and then there's big changes and you may have to prove new testing, right? So there's a real incentive to not change it, right? Because it's expensive to change, the device is working. But when you get to machine learning, you get to these algorithms at the edge, the whole value prop here is that as we get more data about the device's behavior, we're going to be able to upgrade those algorithms. And so now building the software itself around the algorithm, right? So this is a changeable part. And then part of your submission to the FDA is, here is our sub-plan for how we intend to use data to upgrade these new algorithms and push them back out to the edge. And again, you can either spend like years doing it or you can use extensive DevOps automation to actually get you through all of the work that's required to do that. And I love the ML ops branding, but like, if you peel that sticker off, it's usually just a huge DevOps platform. And I don't want to be that harsh, right? Like there's some cool model tracing and tracking stuff that really is a separate layer, but it sits really heavy on, what you're already doing here.
My flippin' toothbrush claims ML.
Yeah, I
It
mean,
might. You don't know. You never know.
It something about it has some sort of, I don't know, gyroscope in it. It detects the position I'm holding it in to tell me which part of my mouth I've brushed long enough. It's not very accurate, but it claims it uses ML to determine this stuff.
That would be great, though. Imagine, if it does get accurate, like just the level of torture that I could put my children through about brushing their teeth properly.
Yeah, wait till it turns green.
Yeah, exactly. I know. Yeah. You're not allowed to go anywhere.
One of the best inventions, we didn't need ML. It's just a toothbrush that plays a song.
Oh.
And you have to brush your teeth until it's quiet.
They have apps for that on the phone too, like, different times to do things like wash your hands and brush your teeth and all that kind of thing. So maybe the ML is like a little bit overkill and I could just be standing around with my kids and making sure they brush their teeth properly.
So another question I have, I think anybody listening is familiar with the concept of a user story. And there's a lot of variations among user stories. Some are actual user stories as intended. Some are just task lists. But what does a user story look like when you are building a regulated medical robot? I don't imagine the user story is, as a surgery patient, I want to have, I don't know, a mole removed or whatever the thing is that a robot does. I don't imagine that's the user story. What do user stories look like when you're talking about these devices?
Yeah. It's interesting because in the agile community and the non-regulated community, we have this discussion all the time. Mm-hmm. In regulated devices, they solve this problem by writing a procedure that defines what they look like. Mm-hmm. So each company will have a procedure about, sometimes multiple procedures about how they will manage requirements. And you don't, like, user story is an interesting, trendy expression, but it's like nowhere in that ecosystem that I'm aware of. They talk about requirements, right? And like people talk about user stories because that's fluffier. And I remember when we started talking about user stories and blah, 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 but like computer scientists talk about requirements, and requirements management is an entire discipline. There's books on it. You got a master's degree in requirements management, right? And so part of the answer is don't call it a user story because that leads you down the realm of weird debate, and call it a requirement and say that you should do requirements management and Google that and go, oh, well, hell, there's a whole way to talk about this. And so they will talk about customer requirements. And so customer input requirements, and it's very similar, right? As a surgeon, I want to do this. I expect this result, but it's very crisp language. They'll have entire rubrics for how to measure them. And how do you measure the output? How do you test this? If you have a requirement, it must be testable, right? Nice. Yeah. Then they will write. And this is one where, right, you go down the road of Jira is the devil and all task management tools are the devil, whatever. Subtasks are the devil, right? That's really where you get to because, and I think most device companies, most regulated companies, I think do a better job of this than almost all software teams. They only do a better job of it because they have to. And it's this simple idea. Oftentimes I have user requirements that I can kind of one-to-one resolve to things the developer ought to do, right? But oftentimes I don't. Oftentimes the user requirement points to three things that the underlying system should do, okay? And so what you often have is there is a layer of user requirements, and then there is a bigger layer of system requirements. And in the system requirements, you'll find all the other non-standard requirements around scalability. You'll find things like the surgeon didn't say, hey, if there's a power outage, I expect the device to do X, Y, and Z. They don't care about that because it's not a clinical outcome, right? That doesn't help the patient. But as a person delivering the system, you did an FMEA, you go back to that risk analysis. Your risk analysis says what happens if the power goes off, right? So now in the system requirements, I'm going to have all these extra requirements around. You have to test the thing for the power going off. You have a requirement that says it has to perform an orderly shutdown after 10 minutes of uninterruptible operation. Okay, show me that you did that with the device, like prove it. And this is where you get to like people signing forms that say, I did this test. So there's tests that you really can't automate, right? But to your question, air quotes, user stories are managed religiously, right? And there'll be one layer of user requirements, one layer of deeper sister requirements. And then behind that is when you'll actually break it down into air quotes kind of stories that the developers are going to eat, right? And that's sort of the third layer. And then under there is where you'll often see people having the argument about subtasks, right? So they manage this by really contemplating requirements management as a much more formal discipline and literally dedicating full-time staff to it. You go to most like startups and mid-ranges and say, hey, we're going to hire an analyst. As a matter of fact, we want like one analyst for every 4 developers, and their only job is to write stuff. And they just think you're crazy, right? In a controlled industry,
I think that's amazing. Like I wish I was places where things like that happen, because they never do. And it would be then, like half the team walks out because of like whatever happened, that half the team walks out and now nobody knows where anything is or what anything's doing or why any decisions were made. But just as a real quick aside, I think every software developer, engineer, DevOps engineer, like whatever kind of title we're giving it to, should go try to find a project where they have to consider things that exist outside the scope of like the software, outside the scope of these like abstract, integrations of classes or whatever that we all have in our head, and go have to consider things that happen in the physical world, like what happens when the power goes out, or what happens if this thing gets dropped, or what if it gets wet, or like what if the robot is having a bad day, like all these kind of things, because it's just it's always like very important considerations that I find a lot of software people just haven't been exposed to enough, and I think it would be all good things for people to just be exposed to that kind of thing more.
The real world is really brutal.
It is.
Like the world of software is pretty safe, but when you start writing software, I spent some time writing, I wrote this integration software that sent jobs to industrial printers. I took this like 1-year deviation in industrial print control and some other stuff. And I had to go get certified as a printer operator. There was just no, and I had to, they were like, you're too dumb to screw up first shift operations. Like you're just going to get in the way on the floor. And so we always start all the noobs on second shift. So you can come in on second shift and we'll have the folks train you. And then we've got a big printer that'll be down on second shift and you can come use your software and test on that. And I mean, I had made no progress. Like it was brutal because I'd cut some code and then I'd have to go send it to the folks on the floor and be like, hey, can you test it? And they're busy. They got jobs, right? Like this is a real machine that costs real money every time you test it. And finally, I just like, okay, I guess I'm going to work second shift for a while. I'm going to be a printer operator. And I would sit with my laptop on top of the thing, write code, build it, and then run a print job and physically take the thing. That was the beginning of me saying, hey, listen, I gotta write real software that interacts with the real world because it's just more fun. There is something about that. There is something about like getting close to like where reality is and then trying to write code that deals with it.
Yeah, that's an interesting thought. Most software development that I've done, like the worst consequence of failure is an error message. Or in some cases, it might be an erroneous credit card charge that your bank can reverse anyway. When the worst outcome is your surgery is botched, or the car crashes
People
into
die.
the wall, or a rocket explodes, it's a whole different ballgame.
Yeah, my first interaction with that was when I was still in clinical research, and it was like the first clinical study that I was on. So why I was even in there is kind of beyond me. But one of the things that was done was when the patients would come in, they would have like, kind of all their vitals taken, and somebody just happened to be looking at like, the screen rolling by of like all the vitals being automatically taken by like our special machines, and be like, that person has really high blood pressure. They're going to have a heart attack. And if they hadn't like happened to have seen that, I don't really know what would have happened to that person, and I don't like entirely really want to think about that. But there are very like real world consequences to some of these things, or for tests that take a while to come back. So I was on a gestational diabetes test, and you do like the blood test, and then they take some time to come back. If those tests are like way out in left field, you need to very quickly be able to contact the person who had that test result so they don't die. Like there's a lot of like just things that you have to think about when you're dealing with not just software but reality, like physical reality, especially if there's people involved.
Yeah, physical reality is it makes it a lot more fun. So physical reality has changed my opinion about a couple of key ideas in software, even, right?
Okay.
So Jonathan, if I told you, hey man, how should we assign catalog numbers to new objects that we're going to create?
Mm-hmm.
You'd probably say, hey, like sequential numbers. Makes sense. What if I said, hey, we're gonna use catalog numbers that encoded in the catalog number are going to be things like the length of a screw and the diameter, right? So like an 0308S
Mm-hmm.
is going to be a 3 millimeter by 8 millimeter slotted screw.
Okay.
How would you feel about that, like as a numbering and naming convention?
I wouldn't mind. I mean, I'm kind of using. I mean, so sort of the data modeler of me in me that I'm writing this SQL schema, for example. I just want a number. It's opaque as far as I'm concerned for the most part. So give me a number. It could be a UUID. It could be what you said. It could be a incrementing integer. It could be a fingerprint scanned as a PDF. I don't care. Give me an opaque number. I'll put it in the database.
Right. So and they want strings, right?
Sure.
And we, on one hand, I totally agree, right? Like I just need a unique key for this table. I need a unique business key. And then on the other hand, though, you ask things like, well, but I mean, don't you already store the length and the diameter somewhere else?
Mm-hmm.
Like the name of the thing is slotted screw. Like, why are we doing this weird construction? And the answer is when you have 50 or 80 different sizes of screws and they're all really little and they're all in one like display case and you're in surgery and you need one of a certain size, all of a sudden having the size and having the screw information in the number
mm-hmm.
makes it more useful to the human.
Right. I can see that for sure.
Like having a number that's not. So there were multiple places across devices, in a previous company where, we'd have these whole discussions about, like smart numbering and should we do it and how annoying it is. Because it causes all kinds of weird problems too.
Sure.
Right. Like letting the users choose. Because what it really means is, hey, when we want to go make something, we're going to go define what is essentially a set of regexes. And we're going to sort of try to protect that whole family of regexes because we don't know how many things we're going to make and we don't know what size variations they are, but we don't, and it might take 5 years before we exhaust all the numbers in this subsequence,
mm-hmm.
but we don't want anybody else to name stuff that matches this. So it produces all these other weird problems at scale, but
right.
like, as a data guy, for 10 years or something, just don't ever use smart numbers was an easy rule. Reality says that they're insanely useful in the real world. And that
mm-hmm.
percolates all the way back to your ERP and your CRM.
Mm-hmm.
Yeah, it's so difficult to do that, though. Like, that's how gene and chemical names are. And then recently there was, like, a funny article. Chemical names are named sort of, like, the name itself is supposed to be informative to the chemical, like the structure of the thing, except there's such a pain to figure out. And then, and to do all that somebody wrote like a machine learning model where they're like, we're sick of doing this. We have a new machine learning model and it'll get you your names most of the time. It was created out of like pure frustration from naming that. I'll bet genes will have something similar at some point, I'm sure, if they don't already. But yeah, no smart names. It's all letters and numbers it's all ID strings.
I make a similar point about version numbers of software. Version numbers are a human convenience for the most part. I mean, there are exceptions. There are tools that require an incrementing version number, for example. But if you're just building a monolithic web service, use the Git SHA, and unless your marketing team needs a version number, and then let them choose it. They want to call it SaaS 2023. Let them call it that. That doesn't have to have anything to do with the version of your code until you have dependency management tools that require Semver or some other schema of versioning. Then you're going to need to do that, and it's always a pain in the butt because then you have to start tagging things according to your human readable versions and whatnot.
So using versioning and having dependency management set up is on my list of minimum required things for a dev team. Mm-hmm. All things will build with a version number from the first commit. Mm-hmm. And we put a bunch of stuff in place so that that's essentially invisible as an engineer. You can start a new module and it'll get versioned automatically and it'll get CI/CD'd and all this other stuff, right? So it's pretty transparent, but I'm pretty religious about, because it's hard to introduce that later, right? Like it's one of the things that as you break software apart, as soon as you try to break it apart, if you haven't been doing any kind of, so I agree. Now, the other version number, which is the more important one, is not Semver or Calver, but it's what we call Marver, which is the marketing version number.
Yeah.
What are you calling this externally? Yeah. Completely divorced from what the actual code says, right? Like go look at the history of Windows releases and then what actually would come out if you typed version at the command prompt across Windows releases. Mm-hmm. Because the internal kernel number is the NT kernel number and is radically different from the Win. Like, I think they aligned them in the last release, didn't they? Did they make a huge jump and the kernel is now all of a sudden it jumped from 6 to 11 or something? But
could be.
Anyway, so yeah, there's the whole what is marketing calling it versus what's the released build. Right. So again, regulated software. You're not required to, but it's very common is if you're going to say that you're in a complete state of control, version numbers are a big part of that, right? Like they're a big unique identifier that will travel with the rest of your artifacts. So I've got a bunch of test results. Okay, great. What build number were they associated with? Right? Like the first thing you're going to get, it's always, and so maybe that's why I'm so intent about it, is that it version number becomes part of the artifact identification.
I agree with that. Even so, that my only distinction is that I think for many services, the Git SHA is sufficient. When there's no dependency between services, if you're building the final artifact, say it's a web service that serves, I don't know, maybe it's Facebook's Messenger service or something like that, right? That nobody ever sees a public version number. There's no dependency on it or whatever. But in that case, the only people ever consuming that version number are people looking at debug logs or debugging events or something like that, and they need to know which artifact caused that error message to happen. And in that case, a Git SHA is probably good enough. Now, if you want to say that you want to mandate version numbers everywhere consistently, I don't have a problem with that, as long as it's easy for the developers to do that. The reason I push against version numbers everywhere is because it often adds a lot of toil. But if you can get rid of that toil, I have no problem with that.
Version numbers, so particularly we have a combination of Calver and Semver. Turns out I think they're both using pieces of both of them is useful. Mm-hmm. It's probably one of the more interesting examples of where smart numbering is useful, and so we build it in out of the gate, because the Git SHA is useful until I start trying to write that in documentation and read it and look at it and talk about it. And all of a sudden saying, hey, I'm looking at the March 22nd release, right? Are you looking at the March 22nd release? All of a sudden all that extra information, which is why we do a combination of Calver and Semver and build number, right? Because all of that context, this is funny because 2.5 years ago when we were starting NeuronSphere, we did huge, I don't know, multi-day religious debate about this exact subject. Like what is the what is the version numbering scheme we're going to use?
Yeah.
Period. Now,
It's all latest.
I'm also a big
just use latest and call it done.
Yeah, it's all latest. Doesn't matter.
Yeah, so
that was a joke, internet. All right, like calm down.
No, latest is fine most of the time. Just 1.* is usually going to get you what you need with most of it. Right.
Yeah, it's all 0.0-dev or latest, and that's it.
And then QA says you have this bug, and you say in which version, and they say latest, and you just go find it, and you're done. You know.
So when we, I'll delve a little bit into sort of like the how do we build things, right? So we take a very aggressive polyrepo approach, right? So literally, multiple Git repos is my assumption. Multiple subversion repos, I don't care. What's your back end, right? Like building software as a set of related components from the very moment you start, right? And again, it maybe it's hard. If you remove the toil, I like your expression, right? Like if you remove the toil, the developers don't even notice this, right? So no matter what kind of technology you're trying to build, all of our repos will track version in the exact same way with a version file that's in the exact same place in the repo. And all of our tooling uses it, right? Like really pervasive, right? And so I guess, attacking dependency management as a very, very first-class citizen maybe was kind of one of the things we went after when we started building our toolkit. Because it's hard, and if solved well, I think you can scale a software team, much, much farther, sort of easier. But you're right, you have to get it completely out of the developers, right? Like you can go download the NeuronSphere toolkit and then HMD repo create and go create all kinds of stuff. And like until you need to really use dependency management, you won't even notice that it's doing all this stuff behind the scenes. So I don't know. I suppose I have to agree with you. It's really annoying to do.
Yeah. Until it's not. Until you solve the problem, right?
Until you say like the user story says as a dev manager, Brian requires this and finds it annoying. So so we satisfy that with solve it pervasively and don't think about it anymore.
So let's talk more about NeuronSphere and the products you guys produce and sell. Just give us an introduction.
Sure. I'm really latched onto. I like this platform engineering terminology. I think a couple of years ago when we started, people weren't necessarily using that. For me, it's just the implication that there's a toolkit here, and that you're trying to build a coherent thing across a series of like really, I don't want to say old disciplines now, but I mean we've been doing DevOpsy stuff for like 10 years, right? Like we've been monitoring systems for like 30 years or whatever. So there's a lot of stuff in there that is just a conglomeration of what we've been doing before, but trying to coherently focus on developer experience and how to unify that. It's kind of been a thing. So NeuronSphere starts with a series of CLI tools and a philosophy about how to build scaling software. So I said, version numbering and dependency management is important. If you go use any of the NeuronSphere tools, they will create repositories that have version numbers and a metadata file so that you can track runtime dependency management. So we do dependency management at runtime, and that's how we solve it. So a big challenge in cloud deployment, so we'll sort of switch over, CI/CD kind of things. I'm going to go deploy this thing. If I'm deploying lots of smaller modules in these smaller repos, I need a way to do dependency management such that my deployment engine can check and make sure that everything's okay before I push my changes, right? And as an engineer, I want the ability to say, hey, listen, here are the dependencies that I want in the target platform. Like if I don't have a VPC, I can't deploy. If I don't have a whatever, I can't deploy, right? And right at that moment, you hit version numbering. Because you say, hey, listen, I'm going to go deploy a microservice, and a microservice requires a VPC named main at version number what or greater. Because that, right, like immediately we can't just say, hey, look, any old version of that thing will probably work. That's not true, right? Like you built your module against a known set of dependencies. And again, it comes to state of control, and you know what you're building and can control it. Because I'm going to use this dependency management. So NeuronSphere's deployment engine and the way the repos are structured, we'll use this to build change sets that it is deploying across multiple environments. So you have a developer, they do their work in dev. We have a video about this on our YouTube channel. So you can go to the NeuronSphere channel on YouTube, and there's a video on there called like drift detection between multiple environments. And this is a common problem. Developer goes, they want to build some isolated stuff. They want to test it and make sure that it works. So I want to go test this in an ephemeral, isolated environment that's mine. And just to do that, I kind of want dependency management because I don't want the entire stack. I don't want the whole solution, but I know that I need a few pieces at certain. So grab me those pieces and their dependencies, bring them down. Let me do some work over here, create some new versions of some modules. And now I'm going to submit those for the pipeline. So they're going to go into dev. And now that they're in dev, we're going to look at the deployed modules. And again, these are standard shaped repositories. We're going to go all the way back to what I said about integration testing, right? So we want to integration test what we just deployed. And, in the DevOps space, I feel really strongly about this, right? We have all these discussions about, should we have multiple environments and how often should we do deployments, et cetera. If you're doing infrastructure as code, right, then deploying the infrastructure as code to an environment, deploying it, seeing if you can apply the change successfully is literally the only way to test it. So the more often you do that, the more confident you can feel in your infrastructure as code, right? Like it's super funny to me. It's like, oh, it's the infrastructure layer. So we save up the changes for a couple months at a time, and then we occasionally do a Terraform plan, and it surprises us. Like, that's bananas, right? And so we kind of combat this. We have a lot of tooling around building small repos that do nice little things. And then you do dependency management on top of those. You have a deployment engine. So now we can deploy all this stuff to dev, and we're going to look in each one of those repos because any one of those repos can kind of advertise that it has integration tests. Right? And you should be able to run those locally. You should be able to run those in your developer isolated environment. Yep, my integration tests are good and they're going to work. Okay, well, now the deployment engine is going to run them automatically in dev. And we're going to do things like stamp the build. So this is where version numbering comes in, right? We're going to automatically stamp the version number and the build number and the environment information. We're going to stamp all this trace information into the test results, and we're going to save it in a central location. We're going to relate it in the graph database to the artifacts that we're deploying. We're going to build all this crazy traceability about, okay, we know exactly what you did in your tests passed in dev. Now we're going to deploy that same change set to test. Now we're going to run the tests again. And this is hilarious. We're going to run the same tests again. Like, this is the default. You don't have to do this.
Yeah.
Just doing this, you'll be blown away by how many bugs you find. I'm going to just try to deploy the same stuff again to the test environment. I'm going to try to run the exact same tests. Yeah. Shocking how many times that doesn't work. We're not even at QA yet. We're still just deploying one module. Damn it, I forgot. Fill in the blank detail, right? Okay, so the engine is going to go. It's going to run your tests. NeuronSphere engine says, you know what? You passed. Now, we talked about CI/CD and industries and can you do continuous delivery? So let's talk about continuous delivery a little bit. Because everything I just described was automated and it was super cool and it feels like very DevOpsy. If you want, you can keep going. You can auto deploy to QA. You can do what you want. You can auto deploy to prod. You can auto deploy to DR. Have a nice day. The NeuronSphere deployment engine, very flexible, happily build that for you. What most people want is a combination of continuous integration, continuous delivery and deployment through lower environments. And then it's a little bit like a reverse mullet, right? So it's kind of party in the front, but waterfall at the back. Because in the beginning, you want all this automation as fast as, it's not fast and loose. You're doing lots of good stuff around controls. But now we've got 6 or 7 different changes that we've gotten into test. And we've tested them all because the integration tests try to test them in isolation as best they can, but they're still interdependencies. And this is critical. We kind of want a snapshot of what change set we're going to move into QA. And I want to be able to deploy that exact same change set into prod and DR later, right? And now we're going to introduce a time delay, because I'm going to create, I've got a function, actually, our deployment service says, give me the delta and build me the change set between any two known environments. And then we'll use that as our starting point to decide what we want to move. And so you do this drift detection between passing things in test, the current state in QA, that gives you a change set. That's the change set that's the trackable release that you're kind of interested in. Now your QA people are going to pay attention. And what is it? It's a list of modules and a list of version numbers. I'm going to apply this set to the known set of list of modules and list of version numbers. I'm going to apply it. And then I'm going to take a version numbered set of integration tests, and I'm going to run it against that in QA. And it's going to produce those same results, and I'm going to store them. Now I can make a determination. I really like this exact combination, okay? Because I'm not doing the continuous, everybody gets to throw their code in the back end of the pipe. That's great. But at some point, like, somebody says, you got to slow down a little bit. Like, we don't do production releases every day. We only do them on Wednesdays or whatever. Like, as much as you want to do continuous delivery, hardcore all the way to prod, it's really hard to get people to let you to do. Right? You can do it with little services that they don't care as much about. But the main ones, okay, now I've got this change set. Okay, roll that to prod when we want to, and go roll that one to DR. And there's conversations we can have about how to warm spare, sort of modify the change set to warm spare on the infra layer and whatever. But that is so we provide a set of CLIs and project templates and really a development methodology to go along with how to build software that will do that whole stack kind of out of the box. We work against AWS right now. We'll be expanding platforms at some point. But you can go pip install NeuronSphere, get all of our local tools, and start doing development and sort of project templating. There's a whole other layer inside there. We have a code generator and a documentation as code tool that we also integrate. So, regulated environments, I think, is a general good practice for developers to do documentation. So in our YouTube videos, you'll see us always switch over to the documentation. And it's generated documentation that comes out of source control repositories that gets built as part of the CI/CD pipeline too, right? So you can always find the right version of the documentation to go with the tests, to go with what's deployed where. So we supply a command line tool for that, and a bunch of utilities. It's really it's the minimum viable toolkit I think a developer needs and a development team needs to be successful. And it starts with a bunch of CI/CD and a bunch of things about version control and a bunch of things about documentation and standards and testability. And you can go look at the NeuronSphere code today. We have about 250 repositories. And if you tell an engineer who's not touched one of them, hey, go look in such and such CLI and make a change. We did this kind of as an experiment the other day. I said, hey, Alex, take me over to this other CLI. I want the following changes. It took 12 minutes to figure out where to make the changes.
Okay.
Because we have a dozen CLIs, but they all look like the same engineer wrote them, right? We have 26 microservices, and they all look like the same engineer wrote it, right? Because we use all these tools that make this polyrepo development experience very, very, very consistent, automated, it also means the developers have lots of portability around the stack, and sort of you can move into a different piece of it because we assemble all software as a collection of those repos at version. So it's literally dependency management for all of the things that you build. If that's a collection of superset dashboards, those go in a repository. They will have a version number. You can set a dependency between those and your Airflow DAGs, which are in a repository with a version number, right? So you can deploy those, and then there's the infrastructure to continue to extend it and add new tools. So it's a kind of a toolkit.
You're speaking my language here with the Airflow DAGs and the superset, and I feel like I could just harass you about that for quite a while. But
so we talk about platform engineering for data because really, a big piece of it is how do you take DevOps principles, how do you do CI/CD and aggressive testing, and apply it to the data infrastructure space where the tooling is notoriously bad at it. I started saying, hey, I caught this bug many years ago writing PowerShell script wrappers so I could do CI/CD with SQL Server stuff because their development team had never thought about like rational deployment apparently. Like that's never stopped. Most of the data tools don't do great at participating in this ecosystem. And so building kind of an underlying substrate, because everybody's got an integration problem now. And it's not an integration problem between platforms. It's an integration problem of all the tools that you need to try to get together. Like how many tools do I need to get together to have QA and prod? If I just wanted two environments, right? And whose job is that? And I think it's the platform engineering team. I think it's the, whoever that is, that some traffic cop that is saying, look, we're the ones that are helping you create multiple environments. But what that means is you need a toolkit to adapt all these tools that don't do a good job of it, or that have a really weird opinion about how you should do it. And really NeuronSphere, look, all the tools that do dev, test, QA, prod, as an engineer, you should have a very similar experience, whether it's Databricks or Airflow or whatever. Right. So what is that like glue layer as a platform team that you use to onboard new tools so that they will quickly behave well and meet your minimum requirements for participation in your larger DevOps and platform ecosystem? How do you add dependency management to all these tools that inherently don't have it? So this is what we use. I don't know if we're the only SaaS that does this. I always like to raise my eyebrow. Whenever anybody says we're the only one who does this, I always raise my eyebrow and go, really? It's a weird world, right?
Yeah.
We use NeuronSphere to build NeuronSphere. We use our own DevOps platform. We use our own deployment engine. We use our own testing engine. We use our own CLIs. It is 100% dog fooded. You can download all the source code, and you would only use NeuronSphere tools to completely rebuild it. And so as can we make life better for developers? I don't know. We will make it as good as we make it for our own developers, but they use it to produce the entire, to produce the rest of the thing. Mm-hmm. And we're pretty lazy, right?
The best developers always are, aren't they?
What was it? The best developers are sloth, hubris, and
I think laziness.
I don't know. I'm too lazy to figure out the third one.
Let's see if ChatGPT knows.
It's the Lincolnstein quote, right?
No, it's Larry Wall, the inventor of Perl.
Okay. Yeah, Lincolnstein.
Best soft developers are sloth,
laziness, impatience, and hubris.
Impatience. Impatience is it. Yep. And hubris, right? Like the belief that I can solve this problem, right? Like the belief that I could take on this problem of this size, coupled with an unwillingness to write much code and sort of an impatience. I want it to be done yesterday. I think you're right. Like it's difficult when you say that to HR, right? Like, how do you judge your engineers? I really look for the lazy ones. You don't put that in the performance review, but behind the scenes, really, it's the how do I write the least amount of code to affect the greatest amount of change?
Yeah, the ones who decide I am sick of this and this is being changed now, and just go do it.
Yep.
Well, we've been talking for more than an hour. I've enjoyed this conversation. You and I, Brian, met a few weeks ago, and I enjoyed that conversation equally. So you're always fun to talk to. But we probably should wrap this up. Jillian, do you have anything ready, or should I go first?
I do. I've been reading a book by Stephen King called On Writing, which is kind of half writing advice from Stephen King and half memoir from Stephen King. If you do not know anything about him, I don't want to spoil the book. He's a very interesting character. He's also an author from the part of the world where I'm from. He's from Maine, and I'm from New Hampshire, which is they're very close. So that was it's been a very interesting read. Stephen King is quite the character. So that's my book.
And he invents a lot of great characters too, doesn't he?
He does, yeah. I forget how much of money produced by the writing industry goes to Stephen King, but he also has books and things. I would not recommend reading his books and then driving around at night in any rural area anywhere, but especially any rural areas in Maine. I'm just gonna throw that one out there.
All right, I'll save those books for not my next Maine road trip.
when you're on like a nice bright sunny beach somewhere where no pet cemetery can jump out at you.
Well, I have 2 picks for the week. I'm going to pick a book also. I just finished listening to the audiobook version of a book by Mariana Mazzucato. I think that's how you say it. It's called The Big Con. Subtitle is How the Consulting Industry Weakens Our Businesses, Infantilizes Our Government, and Warps Our Economies.
I don't know about this pick, Jonathan. I'm feeling personally attacked over here.
I feel like I need a link to this. I feel like an affinity already with this book just based on that.
I think I saw it recommended on LinkedIn or something, but it talks about how some of the really big multinational consultancies, McKinsey, Boston Consulting Group, some of these organizations frequently kind of are, well, it's in the title, con organizations, and how they often perpetrate a conflict of interest, especially when working for government agencies. They talk about the COVID response and military and consulting and stuff like that. How they, they kind of take on. They're literally in some cases advising the government to buy services from their own clients. And other ridiculous things. So it's not a treatise against consulting as a profession. It's really about specific ways of consulting that are problematic. So, I consider myself a consultant also. So, I felt personally attacked a couple of times, but I don't know. I think we could those of us who are consultants could take this as a warning of what not to do. My second pick is a little more lighthearted. I run another podcast that started earlier this year called Cup of Go, which is about the Go programming language. It's a weekly news program about what's new in the Go community. And we've recently started selling merchandise. And just today, my Cup of Go cup arrived in the mail.
I was going to comment
I'm
on
so
your
excited.
Mug. It's really cute.
It's so cute. I love it. If you're watching the video, you can see it. If you're listening, you'll have to go to cupofgo.dev to see what it looks like. But that's my second pick. These cups are just cute. They're $20, including shipping worldwide. So, Brian, do you have a pick for us?
I'm going to give you a pick. It's a tool, because I'm a Tool guy about half the time. I mean, first, Tool the band. Like, if you don't listen to Tool, you should definitely listen to Tool. But no, in the tooling space, and I found this one a number of years ago, but I swear everybody I bring it up to, I've never heard of it. There's a tool called Robot Framework. And Robot Framework is a test automation tool. It is not a browser test automation tool, right? Like, it's not like a Selenium competitor.
Mm-hmm.
It's sort of a level above that. As a person who's like been through multiple programming languages, I love frameworks, I love tools. Really, this one has been incredibly impressive. When I talk a lot about, doing integration testing as part of your delivery process, I'm always doing it on the assumption that you're using Robot Framework, because it makes it like useful and easy. It produces, you can use it to produce test output that reads like a story, and like QA loves and end users love. It really, when I talk about like how to make testing valuable and how to really do this at scale, it's always because Robot Framework is behind it. So it's a testing tool. Don't be scared. It's insanely extensible if you're into Python. It's really extensible with just a tiny sprinkle of Python. But really, it's like a DSL making tool for testing. And there's a global community. They have a global user conference for Robot Framework every year, right? All the QA nerds all get together. But if you're looking at different ways to do testing or thinking about how to bang on systems, whatever, Robot Framework, I really can't recommend it enough.
Awesome. I'll check it out.
Totally open source.
Yeah, that's cool.
Very cool. Well, Brian, Jillian, this has been fun. Thanks everyone for listening.
It has been.
Hope to see you here next week for another adventure.